So, congratulations. We are already at the end of this session on advanced object types. This was not only the end of this session, but was also the last session on the fundamentals on R. So you get the most boring part behind you. But I think it was really worth the pain, because what you did in the previous sessions is that you learned about the most important object types in R, and how these basic object types can be turned into advanced object types by adding attributes. This is terribly important because functions do different things when they are applied to different objects, and therefore understanding different object types is absolutely fundamental. I'd say many people who start using R and then directly delve into applications of visualizations or working with data frames, etc., they are missing the specifics of these fundamental object types. And well, this won't bother you at the very beginning when you are using with some clean pre-specified data frames. It will cause a lot of trouble once the data frames are taken from the real world. They do not have the nice shapes. You get error messages. It can be frustrating. You won't understand them if you don't understand these basic object types and how functions work. So I think it was really a good idea to start in this a little bit more abstract way. So just to wrap up, we focused on vectors here in the previous sessions. We distinguished between atomic vectors, vectors that contain elements only of the same type, and we looked at lists, generic vectors. These are vectors that can contain elements of different types. The main four base types of atomic vectors were logical values, true, false, integer, whole numbers 1 to 3, double, decimal numbers, and character like strings or names. Today we encountered the factor as an extension of the integer that we can use to encode ordinal or cardinal, ordinal or categorical data. So it's good for situations where you have data that can take only a number of pre-specified values that we call levels. I also suggested that usually it's a good idea to save the data in the form of characters and then turn them into factors whenever that's necessary for the analysis, because usually the underlying data has more the type character, and then working with something that's actually a fancy integer can be confusing. The second more advanced object type we encountered was data frame, or its more modern version, the Tibble, which is basically the data type we encounter a lot when we work with real-world data, because whenever you load data into R, it usually has the form of a data frame. And in the context of data science, well, data frames are obviously of prime importance. Since data frames are so fundamental to R, they are also related to the different dialects of R. So the data frame as such is associated very much with a base or classic dialect. These are people who use mainly functions that are already pre-specified in R. We here work a lot in the tidyverse dialect. It's developed by the people who also developed our studio here. Data frames are usually transformed into tibbles. And then there's also the third big dialect, data table, where the data frames are turned into data tables. This is extremely fast. It's basically mandatory to use when you work with really big data sets. It's also a little bit more difficult to master, at least in my opinion. We talked about functions before. We haven't talked about nulls so much. You find more information in the course tutorials, but for now, I guess things we covered in the previous sessions, they should make you comfortable to use R already in many basic sense, and they put you in a perfect starting position to learn about the more advanced techniques that make R so powerful when it comes to the overall topic of data science.